Okay, so we're going to be working through homework number 3, which involves naming of ionic compounds, and especially compounds that have more than one oxidation state. So the reason we do this is because if you look at a name like iron oxide, we know that that contains iron, Fe, and oxygen O, and then we look on the periodic table and we see that O is a charge of -2. But if we look at the periodic table for iron, we see that there are two. There's +2 and a +3 for iron. So we don't know, based on the name right now, whether we're talking about iron Fe2+ or Fe3+. So the name iron oxide doesn't specify. So we have a system with the Roman numerals and parentheses that show whether we're talking about iron 2 or iron 3. So if we have, say, a compound like this, Fe2O3, and we want to now figure out if it's iron 2 or iron 3 and what the name would be, we know that in any ionic compound, the charges have to add up to 0. So the charges have to add up to 0, and we know a couple things already. We know that oxygen has a -2 charge. You look on the periodic table, oxygen always has a -2 charge. And we know we have 3 of them, so 3 times 2 equals -6. So here, we want to find out what the charge on iron is. We want to find out what X is here. And there are 2 of X, so it's going to be 2X minus 6 equals 0. So here, just like in math class, you solve for X. And when you solve for X, you're going to see 2 times 3 equals 6, minus 6 equals 0. So we know that in this case, we're talking about Fe3+. So if we were to name that, we would name it iron 3 oxide. So if we're going to do the same thing with the other iron, if it was iron oxide and it looked like this, FeO. So if we look at this, we're doing the same thing now. So we're going to now, you know the charges add up to 0. So charges add up to 0. You know that oxygen has a -2. There's only one of them, so it's going to be -2. And then iron, we're looking for X. Separate it out a little bit. And you know that there's only one of each of them, so it's going to be 1X, or just X minus 2 equals 2. So that gives us X equals +2. So iron, its charge is +2 here. So we're talking about iron 2+, so we have iron 2 oxide. And it's important to note the oxidation state in parentheses because we want to know if we're talking about iron 2 oxide or iron 3 oxide. One of them has a formula of Fe2O3 and one of them has a formula of FeO. They're 2 different formulas. So whenever you're naming an ionic compound, take a look at the periodic table. If you have a metal with just one oxidation state, then you don't need a parentheses, you don't need the oxidation state because there's only one possible thing it could do. For instance, if you look on your homework, we have calcium, that is one oxidation state, and Sc just has one oxidation state. You're looking in the top right of the box. But then titanium and vanadium right next door have 3 and then 4 oxidation states. So when you were naming, say, anything that's titanium, say if you're naming titanium oxide, it would be titanium, then the oxidation state, then oxide. And same thing with vanadium. So anytime you were naming a compound with either of these or any other metal with multiple oxidation states, you've got to include the oxidation state. So if we look at question 1 just asks you to go through and circle any of the compounds with more than one oxidation state. So let's look on the periodic table. Iron, multiple oxidation states. Calcium, just one. Sodium, just one. Cobalt has multiple. Ammonium is not even a metal, it's a polyatomic ion. So if you look on table E, it just has one charge, so it's just +1. And then zinc. So while zinc is a transition metal, and most of the transition metals do have more than one, zinc only has one. And then vanadium has a bunch of different oxidation states, so we're going to circle that as well. So now going through the first 3 questions here, we have FeO, Fe2O3, and PbS. So if we were to name these here, and we know it's going to start out as iron, and it's going to end with oxide. Iron oxide, and now we're going to do the same work we did before. So if we have Fe and O, we know a couple things already. We know that oxygen's oxidation state is -2, and we want the oxidation states to equal 0. Separate it. So -2. We're looking for Fe's oxidation state, so it's going to be X minus 2 equals 0. So X has to equal 2. So this is going to be iron 2 oxide. And now let's do that same thing with Fe2O3. So Fe, we're looking for Fe's oxidation state. FeO, and it's 2O3. We know oxygen's oxidation state is -2, and we do our math above. So you do the math, we know that the charges are going to equal 0. So 3 times -2 equals -6. 2 times x. So 2x minus 6 equals 0. X has to equal 3. So 1, 2, 3. And now let's do PBS. So I'm going to do PBS on the side here. We've got PB and we've got S. And this is PBS2. So let's look up the oxidation states. We know that S has an oxidation state of -2, and we're trying to find leads. So let's set up our math here, and we know that the oxidation states are going to add up to 0. 2 times -2 equals -4. 1 times x is just x, minus 4 equals 0, so we know we're talking about lead 4 sulfide. Another way of thinking about it here, and I've pointed it out as a hint in the box, let me fix that E, is think about the charges. What is the charge of S? It's -2. You look on the periodic table. How many of them do you have? There are 2 of them. So what would you want the charge to be of Pb? So it would have to be +4 to balance out that -4. So when you are going through the oxidation states, make sure that you are including the when you are writing the formulas, rather. So whenever you're writing the formulas, make sure that you are solving for the oxidation number, and whenever you're writing the name of it, make sure that you first check to see if it has multiple oxidation states. If it does not, then you do not need to write the oxidation state in a parentheses. If it does have more than one oxidation state, you must include the oxidation state. So you could use this method of writing the oxidation states to write any of them, and I've got a few more examples here. So let's go through. These molecules were all of the ones from that first question that you circled, the ones with multiple oxidation states. So let's just go to the last one. We have VO2. So we have vanadium oxide, but that name doesn't tell us the oxidation state of vanadium. So it's going to be vanadium something oxide. So we set it up in the same way. VO2. You know that the charge of vanadium is, or I'm sorry, you don't know the charge of vanadium. You look at the periodic table, there are 4 possible options, but you know the charge of oxygen. Charge of oxygen is -2. So in many of them, you can just do a reverse crisscross here, and you could sort of bring up the 2 and bring it up to the other side, and that would be a +2, but that doesn't work on all of them, and that doesn't work on this one, because if you remember, if you have an empirical formula, that's the most reduced form. So when you crisscross the charges, and say if you were to get like, say, PB2O4, you would reduce this down to PbO2. So you would wind up with a formula that you can't just work backwards and crisscross. So doing this method where you're showing the algebra above is the best method for determining the charge. So we have 2 oxygens. Each oxygen carries a -2 charge. You know it's going to add up to 0. So 2 times -2 equals -4 equals 0. And you're searching for x. So 1 times x minus 4 equals 0. So we know we're talking about vanadium with a +4 charge. So we're talking about vanadium 4 oxide.